Hi everyone, my name is Luca Garello and today I'm going to talk about our paper, A Generative Model Towards Conditioned Robotic Object Manipulation. If we observe another person moving an object, we can not only interpret the scene, but also gather additional information about the object that is being manipulated. For instance, its weight. Unfortunately, robots don't have this ability. To this extent, we propose a generative model to produce synthetic motions that are communicative of the properties of the handled object. Moreover, in this way, we are able to produce motions without necessarily copying and replicating human examples. To generate new velocity profiles, we propose a conditional generative adversarial network. The architecture can be conditioned by a label in order to produce a velocity profile belonging to a particular class of action. In particular, we focused on movements that involved fragile objects, and we considered as motion descriptor the velocity of the end while performing the transportation movement. In a second phase, the generated velocity profile can be used for controlling the end effector of a robot. In these videos, you can see examples of the transportation motion used to train the generative model. We calculated the velocity norm of the participant's hand from a motion capture marker positioned on the metacarpal bones of the right hand. We considered two glasses with equal weight, one filled with water till the brim, therefore requiring a great care in being moved without spilling water, while the other one was empty, except for some coins used to reach the same weight. The dataset consisted of around 500 examples in total, and the movements were performed by 16 volunteers. The architecture takes as input a vector of random noise and a conditioning label that describe the class of data we want to generate. In our case, we used a binary label, 0 for not careful actions and 1 for careful actions. Such lower dimensional embeddings describe temporal dynamics of the new data. In fact, even complex systems are often driven by fewer and lower dimensional factors of variation. Finally, a decoder that was previously trained on the original data is used to reconstruct the generated synthetic embeddings. Here we show quantitatively some random examples of generated and real velocity profiles. The generated data are represented with their continuous lines and prove to be similar to the real ones. When projecting the data in a lower dimensional space with a t-SNE, the distributions of real and synthetic data are comparable. It should be noted how generated data are not a trivial copy of the input, but they give us a coherent representation of the original classes. The distinction among the careful and not careful gestures is preserved also in the synthetic profiles. Finally, we can see a robot manipulating an object with two different synthetic velocity profiles. To conclude, we can say that our model is able to generate motion representation coherent with the ones humans adopt in handling objects. A deeper assessment of our model should be carried out in the future. However, our approach is prone to be generalized over new and different features implicitly conveyed by our movements, such as the weight of the object or the emotional attitude. Moreover, our model could be conditioned in producing velocity profiles intermediate between the classes used during the training. The effect of such modulation should be investigated in the future. Thank you for your attention.